Now from example 1, we actually went ahead and took the derivative to figure out what is the tangent slope of the function at any particular x value. And that's pretty much what we're trying to figure out with example 1 continued, is what is that tangent slope of that function at, let's say, this particular x value or this particular target point. So again, back from example 1, we said that the derivative f prime of x came out to be 2x. In other words, the tangent slope of this particular function at any particular target x value we want came out to be equal to 2x. And if we want to then figure out what is the tangent slope at this particular target point, all we really need to do is throw it inside the function. So f prime of 1, in other words, the tangent slope of this function at 1, comes out to be 2 times 1. And as a result, our tangent slope just comes out to be 2. Now, again, that's just the slope of the line. But from that information, we can go ahead and construct what is the actual equation of the line. Well, right now, all we have is our target x value. And from that, we can go ahead and throw that into the original function to determine what is the corresponding y value. So f of x, if you recall, was x squared minus 1. All we need to do is throw in 1 into the function to see what is that corresponding y value. So we end up with 1 squared minus 1. 1 squared is just 1 minus 1, so it looks like it comes out to be 0. So in other words, at 1, we ended up with the y value 0. And again, this is our target point that we're trying to figure out what is the equation of the line that's tangent to this particular target point. So graphically, what's going on, just a quick sketch, would be you'd see some quadratic doing something like this. And then at this point 1, 0, we should see a tangent line doing something like that. All right. Now, if we're trying to figure out what is the equation of that, all we really need to do is use point slope. So that's y minus y1 is equal to m times x minus x1. Well, we already have our tangent slope that we're going to use. It's 2. And we also have our x1, y1. So pretty much all we need to do is throw those values in there. Here would be your x1, y1. So we end up with y minus 0 is equal to our tangent slope we saw again was 2 times x minus our x1, 1. And now we're just trying to solve for y. So y minus 0 is just still going to be y is equal to, on the right side we can go ahead and distribute, giving us then 2x minus 2. And we can even kind of see that from our graph. We can see that it would have this line, y is equal to 2x minus 2. In other words, that y-intercept would be kind of like negative 2. So again, here is our equation of the line that is tangent to this target point of 1, 0 of this particular function. Y is equal to x squared minus 1. But again, though, that is example 1 continued from our 2.2 number 2 set of notes.